How are you doing? Good morning. Good morning. So I'm so excited to talk with you guys this today. We're going to be continuing our transformation unit. I want you to pay attention, pause the video if you need to, take notes if you need to. The worksheet is attached. You can print it out. Right now on the worksheet I'm using, you don't see the actual video code at the top, but there will be a QR code to this video if you need to look back at it at any other time. All right, so let me share with you the worksheet for what we are working on today. All right, you should be able to look at my screen, which I personally don't see it yet. So let me. Hold on one second. Let me just find my worksheet. Ah, there it is. Okay, let's try this one more time. Sorry. Good morning, everyone. All right, so what you should be looking at is this worksheet right here in front of us, right? It says properties of reflection over an axis. Now, we have talked about one transformation so far, which was the translation transformation. And the key word there was to slide an image or to move the image, whether it's up, down, left, or right. Now, this second transformation that we're going to talk about in Math 8 is a transformation called reflection. We're going to talk about translating it over an axis, either the y-axis or the x-axis. To start us off, let's work on the bell work. Let's start off by doing the bell work together. It says identify the coordinate of the pre-image and the image, and then they ask you what are the coordinates of A prime, B prime, and C prime. So take a few minutes, pause the video right now, and fill in A, B, and C. What are the coordinates for A, B, and C? And what are the coordinates for A prime, B prime, and C prime? As you can see, that both of the triangles are on our coordinate plane here. So what are the coordinates for both of those triangles? All right, so take a second to write that down to the best of your ability, okay? Hope you paused the video. Hope you wrote down the answers. I'm gonna now go over the answers with you, and then we're gonna continue to go on. Okay, so you'll see frequently throughout these videos, I'm gonna ask you to pause it, to write down your answers, to reflect, or to go over something on your own, and then a little while after that, I'm gonna go over with you. So I hope you took a second to pause the video and to write down your answers. If you didn't, once again, take a time now, pause it, and then go over it. Pause it and then write them down. So let me go over it with you. So when you looked at the coordinates for each one of these, right, A, B, C, and D, right, you should have been able to get all three coordinates for A, B, and C. So A, the coordinates of A would have been 4, 3, right? B would have gave you 7, -1. Sorry. Okay. Let's try this again. So 7. -1. All right. C would have gave you 2, -2. Right. And these would have been your first couple. And then when you went over to look at A prime, right? A prime would have gave you -4. Right. -4, 3. Sorry, I'm just looking and getting it. B prime would have gave you -7, -1. And finally, this would have gave you -2, -2. Now, right, I asked you in the reflection, what axis do you believe that this pre-image ABC, the blue one, right, is reflected over, right? What do you think this one is reflected over? And if you were looking at the actual graph as well as I am, you would have noticed, and I'm going to use an orange here to draw out this line, right? This line right here, my orange line that I'm drawing, right? This line is trying to go right over the y-axis. And an axis is a point. It's a line, rather. It could be a point. But in this case, it's a line. We're talking about line of reflections. So this is the line. Y-axis is the line of reflection here that we're using to flip this image over. So in other words, a keyword for reflection is flip, right? We're flipping an image over a line of a reflection. So in this case, you can see that triangle ABC was flipped over this orange line, or rather the y-axis, to create A prime, B prime, and C prime, right? So if you was to write your reflection answer, you're gonna write that was flipped over the y-axis. So that's what we would write here. We would write y-axis down here, okay? And I'm still using orange. So let me go back to using red. Red just pops a little bit more. Maybe I'll use black in a second. All right, so great. So that's our build. Now let's go on to looking at the rules for a second. All right, and I'm just gonna have to erase the text. So if you need a second to copy it down, copy it down. I'm gonna erase it. And boom. All right, so let's go. We want to talk about the rules. Now, if you would have noticed, what happened when we had those coordinates? So I'm just going to redo and put them back up here for a second because I want them to be here. Let's see, will it give them back to me? Probably not. Oh, okay. I was hoping that was going to work, but it didn't. All right. So either way, when we did the coordinates a little while ago, you would have noticed we had A was 2, 5, and we had, I'm sorry, A was 4, 3, and A prime was -4, 3, right? Only thing that changed when we flipped it over the y-axis was the x values, right? And the reverse is true as well. So when we look at the coordinates, right, when we look at changing coordinates, when we're flipping them over, whether it's the x-axis or the y-axis, there's something that happens. So I'm going to explain to you the change that happens when we flip over the x. I'm going to explain to you the change that happens with the y, and then I'm going to write the coordinate notation as well. Then we're going to practice, and then you're going to allow yourself to hopefully get better. And if any questions you have, you can still ask me. So what changes happen to the coordinates when we reflected over the x-axis? So x actually stays the same. Sorry, I keep leaning on this, so it keeps dragging it. The x stays the same. So x stays the same. Right? But the y is the opposite. So it's x stays the same, and then we have the opposite, or we could say the inverse of y. So, and then we have the inverse of y, right? And if you remember, inverse means opposite, right? Inverse of y. I'm still getting used to the hang of this, so I apologize for that. Inverse, I'm sorry, of y. Okay. Now, what does that look like in terms of its coordinate notation? Now, the coordinate notation for this looks something like this, right? X and y, they go to, x stays the same, so x is still going to be there, and then the opposite of y, which is going to be a -y, right? So if y was originally 4, now it's going to be -4. If y was originally -4, it's going to turn to a +4 because it does the opposite of that. So we're going to remember that if we are reflecting it over the x-axis, which is, it's this bottom line up here. If you look up here, it's that bottom line, the dark one that's horizontal, right? If we were to flip it over that axis, we're going to say, okay, keep the x value the same, but do the inverse of y, which means, you know, negate the y. If it was negative, it turns positive. If it was positive, it turns negative. Now, if we were flipping it over the y-axis, what happens there? Okay, when we flip it over the y-axis, exactly is the case. Y is going to stay the same now. And this is what we did a little while ago, right? We noticed that y is what stayed the same. right? Y stays the same, but we have the inverse of x now, the inverse of x. Well, that, and just so you know, that doesn't change the way the coordinate is. It's still x comma y, but now it's going to be the opposites here. So the inverse of x. So let me just put that here, and I'm going to show you what that notation looks like. Okay. So the notation looks something like this, right? We have x comma y, and they go to, right? We have x comma y, and they go to, let me just finish drawing this little arrow, right? They go to negative x, comma positive y, which means that the x's is changing here and the y is staying the same. So x changes and y stays the same. So let me do an example right on this bottom here, right? Let me give you an example of a matter of fact, it might be better to do an example over here, actually. Let me do an example over here. Let's do it as a coordinate, let's say 2 comma 3. Right, if the coordinate was 2 comma 3 and it was reflected over the x-axis, we would keep x the same, 2. Sorry, it's lagging a little bit. Let me try this again. 2 comma negative 3. Right? This is what we end up having, 2 comma negative 3. Now, if we reflected over the y-axis, it will look something like this, negative 2 comma positive 3. Right? Oh, sorry, give me, there it is, okay? Right. So we would have it as, this is what it looks like when it's reflected over the x. This is what it looks like when it's reflected over the y. Right. Notice when it was reflected over the x didn't change. The y did. When it was reflected over the y, the x changed, but the y did not. So that's important. So we're talking about lines of reflection. We're talking about the rule of reflection. Sorry. If you haven't copied that down, take a second to copy it down. All right. I'm going to clear the text. All right, let's keep going. So what we're talking about is reflection. So the essential question is, how do you describe the properties of reflection and their effects on the congruence of figures? Now, just like with translation, the figure is not changing at all in terms of its size or shape. So that means it's still congruent. It's still the same exact figure you've seen before. Only thing that's happening now is just flipping. It's moving across the coordinate plane, but the lines are still the same size. The angles are still the same size. The image is still the same size and shape. It's just moved at a different place. So the congruence is still congruent, still the same measurements, right? We're just reflecting it or flipping it over something called the line of reflection, which is a line, right? It's a line in itself. It could be the x-axis or the y-axis or any other line on the graph. Now, today we're only focusing on flipping it over the x-axis and flipping it over the y-axis, but we do want to be able to flip it over other lines of reflection as well. So let's go to the next page. I'm going to model one for you. And then what I want you to do is I want you to be able to complete the rest of the work problems. Now, I believe there are 4 problems for you to do, right? And they're only asking, or probably 3, and they're asking you to take an image, flip it over the X, and also flip it over the Y. I'm going to show you what that looks like right now with the model, okay? They gave me a triangle ABC, right? I need to first identify what are the coordinates of ABC. Now, I believe for you, I already gave you all the coordinates for your images, so you don't have to worry about the original, the pre-image. You don't have to worry about the coordinates of the pre-image because I gave them to you. But you have pictures as well, so you can always identify them, right? You need to be able to reflect it over the X. Now, why am I showing you the picture and I'm asking you to identify the points of the 2 other images? The reason is maybe when you printed this, maybe you can't print it out, right? And you can only write down the points. That's fine. If you are uploading this assignment and you do not have a printer, so you wasn't able to print the actual worksheet out, and you can only tell me what the new points are, that's fine. I'm looking forward to you saying problem 1, A prime is this, B prime is that, C prime is that. I don't need to see the actual image. But if you can draw the new images and you are able to print it out, or you was able to create your own coordinate plane, please do so, okay? I think it'll help you. It'll help you visually as well, because I want to show you a visual way to be able to do this as well. So the first thing I want to do is identify A, B, and C. Now my A, B, and C of this triangle right? Make sure I'm actually on here. Good. So my A is 2 comma 5, right? That's what my A is, right? Let me make sure this is still working here. It's lagging a little bit. Might have a better chance of just using the pad. So 2 comma 5. Okay. 2 comma 5. All right. B is 6 comma 2. And then C we have is 2 comma 2. If identifying points is still very hard for you, and that's a 2, I'm sorry, right? If identifying points is still a challenge for you, I recommend going on Delta Math and going back to some of our previous assignments to practice identifying points, right? I believe that was one of our last actual homework assignments on Delta Math, was to practice identifying points to get us ready for transformations at this level. Now, I need to reflect it over the x-axis. And if you notice with me, right, this line right here, and I'm gonna make it, let's make it a green, right? This line, sorry, okay, this line, this green line that I just drew, that's our x-axis. So if I'm trying to flip it over the x-axis, I need to make sure it gets on the other side of this line. If you notice, if I were to flip it, if I folded this in half, this C should end up right here. Now, how do I know that? How do I know that? Now that's not hard to figure out. I'm going from this point, from how far is this point from this line? I see it's 2 spaces. So if I were to flip it, I know it needs to go 2 spaces down from the other side of that line, right? The x value is not changing. Why is the x value not changing? Because we said before that when we flip over the the x-axis, the x value doesn't change. So x value does not change, but the y negates. So it was originally a positive 2. Now it's a negative 2. So if you wanted, you could use the rules we talked about earlier, or you can actually use the diagram to fully graph it, but you still need to identify the correct coordinates. So here I would say, okay, x is 2 and y is now negative 2, right? This is the change that I see happen. I see it was originally a positive 2, now it's a positive 2, negative 2, because it says the x-axis. X doesn't change. So what you're saying, Mr. Riffer, is I could tell you that all of these are going to be the same x points. Yeah, that's going to still be a 2. That's going to still be a 6 because we're flipping it over the x-axis, which means x does not change. However, the y's negate. So that means that this 5 needs to become a negative 5. That 2 needs to become a negative 2. And these will become our new coordinates for A prime, B prime, and C prime. And if I were to do the same exact thing, you would notice, yeah, B is right here. What point is that? B prime is what? 6 comma negative 2. Is that what we have here? Yeah, great. A is 4 spots away. So I'm gonna go 2, 4, and put a new A prime right here. And that looks like it's actually 2 comma negative 4. Sorry. 2, 3, 4, 5. Oh, sorry. I have to go down one more space here. I apologize. Right? That's A prime. Right? That's A prime right there. Get rid of that other dot. Okay? That's my A prime. And now you'll notice, look, I have the triangle that I wanted to create. Now that I have this triangle, of course, you can connect all the dots. Make it as pretty as you can get it. I'm using a tool, so mine's gonna look nice. Yours, I hope you use a ruler if you can, or a straight edge of some sort. But that's A prime, B prime, and C prime, and that's the first one that we've done, reflecting it over the x-axis. Now, the second part of this assignment is not only reflect over the x, you also need to practice reflecting over the y. Now, any given quiz or test I'm gonna give you, I may not ask you to do one image over both, but I will have you do it over. Shasha bit you? All right, I'm gonna go pop them in a second. Go tell mommy. Go tell mommy as well. Welcome to home teaching. Okay, cool. So let's do one more. Let's reflect it over the y-axis. Let's reflect it over the y-axis. Go to mommy. Let's reflect it over the y-axis. And then what we'll do is I'll recap everything we talked about, and then you'll have to complete the assignment on your own, and please upload it as well. So let's do it. Reflecting it over the y-axis. I'm gonna make this color, let's make this a different color than that, or the blue that's there. Let's do brown, okay? Now, once again, it says y-axis, right? This is a y-axis. It's telling me to flip it over. This brown line is the y-axis, okay? That is our y-axis. We need to flip this original image. Now, I want you to pay attention. I don't want us to flip the new image. I want you to keep going back to the original image. This is very important. Everyone, listen to me again. When you go to flip the image, I want you to go and flip it from the original, not from the new one, okay? It's easy to go from the new one to the next one, but I want you to go from the original to the actual, I don't like that. I like that. That's fine. I already said it. So since I said it, let's do it. All right. But in some cases, you will have to go from A prime, B prime, and C prime to the second one. But in this case, I want you to go from the original image to create this new A double prime, B double prime, and C double prime. So I notice, right, once again, they said y-axis. That means that all the y values are going to be the same as the original. So if that was a 5, that means down here is going to be a 5. That was a 2, that means down here is going to be a 2. That means over there is going to be a 2. Now, how do you notice, Mr. Wilfred? All right, let me show you again. We're flipping it over this line. So if I wanted to say A double prime would be somewhere right here, because I see that it's 2 units away from the y-axis. So A double prime would be that. What is that point? That point is -2, +5. So -2, +5. Notice 5 is still there. Perfect. I got the 5 right, but -2, where did they get -2 from? They negated the original A, right? The original X value of A, they negated X. So it became a -2. It was the opposite. So if it was let's say, for example, that was a -2, that means that this would have to be a +2, okay? So that became -2. And you could do that with each one of these points. You can move them over like we did, or you can say, okay, I need to negate the X because Y stays the same here. That means this will become a -6. Sorry. -6, this will become a -2. And when you go to graph all of these points, you'll get C double prime right here. And then you'll end up getting B double prime right over here. Okay, and that's supposed to be a B. Excellent. Once you have that, connect all the lines once again. And congratulations, you just worked on using the second transformation we have learned, which is reflection, okay? Now, I want you to complete the next 3 problems that we have here. I believe there are 3. Let me just double check them so that way I'm not lying to you, right? Hold up, let me give you a second. I'm so sorry. If you need to, pause the text, pause the video, copy down the text. That way you have it. I'm going to clear it in 3, 2, 1. All right. So what we end up having here is you have one problem here that you have a triangle, right? You have to translate reflect these 3 points over the X and over the Y, just like we did, okay? The next problem that I give you is a quadrilateral, right? You have to reflect all 4 of these points over the X and over the Y. And then the last one is another triangle again. So there's only 3 problems for you to do, reflecting over the X and over the Y. Reflection, once again, is our way of flipping an image, right? That's the key word, flipping an image. You should have been able to copy down the rules on the first page. And if you have any questions, please leave them in the comment box on Google Classroom. Thank you guys so much. Talk to you later. What is it, buddy?